Well, good morning for calculus. I am here inside of the WAMAP called Adding Vectors Graphically. I'm going to take a look at a couple of the some of the questions out of that assignment as examples. So we'll be doing questions 2, 4, 6, 9, 12, and 14. So if you're looking for something out of one of those different sections, you can skip ahead if you want. Okay, so we'll start off with number 2. So we're given a vector A with components -1, -9, and we are supposed to do a scalar multiplication here, -3 times that vector A. So I'm just going to do some quick mental math while I type in my pointy brackets. So I got -3 times -1, that's going to be +3, I need a comma, and then -3 times -9, that's going to be +27. There's my components. Close that pointy bracket. I've got correct notation. It's not giving me any error messages anymore. I'm going to submit. This is a multi-part problem. Submit, and the next part shows up. Now I need to graph one vector to show that entire scalar multiplication. So I know in the lesson video, if you watch that part, I showed for scalar multiplication, if we're doing like 3 of a vector, you're going to graph like 3 of them. But WAMAP wants us to just do the one vector that shows that whole thing. So I just need one vector that's going to show 327. So this is wow, it's a huge graph. So I'm going to go down here to the origin, 327. Yeah, okay. So I'm going to start here, boop, and then just click and let go. And then that arrow is going to follow my cursor around as I move that. So I'm going to go up there to 327, click, submit. Yay! Super. All right, jumping over to number 4. Okay, so we got a vector addition this time. These vectors are not named, but here's the vector 1, 3, and another one 4, 6. I'm going to graph this. It says graph the following vector addition starts from the origin. So we're going to graph a total of 3 vectors, one vector to show the first. I'm going to draw one vector to show that first vector, 1, 3, a second vector to show the next vector, 4, 6, and then a third vector to show the resultant. Okay, so it starts from the origin. Click and let go. Over 1, up, whoops, up 3, click and let go. So there's my first vector. Okay, so this is like the confused student wandering around the neighborhood. After you wander in this direction, you don't automatically like transport back home to start over again. So I'm just going to go head to tail. So clicking again, right at the same place I just let go of my mouse button, and you see I've attached another vector right there. It's going to follow my cursor around. Okay, so from here I need to go 1, 2, 3, 4 spaces over. 1, 2, 3, 4, 5, 6 spaces up. Click, let go. All right, so there's my vector addition. Now I need a resultant. So here's the pigeon. Click on home. That's where the pigeon starts. Click, coo, coo, and stretch that thing out to end at the exact same place. Click and let go. Hooray! All right, submit. Get the green rectangle. That's correct. Last part, find what's the component form of the resultant. Well, all together, I'm just looking for what the pigeon did, right? All together, those two vectors added up to make uh, 5 spaces in the x direction and 9 in the y. So pointy brackets, 5 comma 9, close my pointy brackets, submit, and that's correct. Hooray! All right, let's jump over to 6. Okay, so number 6, it's a subtraction question. It says graph the following vector subtraction. So I've got my vector 0, 1, subtracting this other vector, -2, 5. So to do subtraction, I'm going to have to change that subtract into adding a -1 scalar multiplication. So it says first we need to change subtraction to adding a negative. In order to do that, we're going to rewrite subtraction. This original subtraction problem, we're going to rewrite as 0, 1 plus, and then -1 as a scalar multiplication, -1 times -2, 5. Okay, so we're going to do the scalar multiplication here first. So -1 multiplied by -2, 5 is going to change the sign. So this will be 2 and -5. Submit a multiple part question. So the component form of that scalar multiplication first. Next, graphing. Okay, so start from the origin. We're going to graph a total of 3 vectors on here. The first one shows the 0, 1. So I'm going to go 0, 1 right there. Click and let go, click and let go. None of this dragging business. Um, Second, From the end of that vector, I'm going to draw another vector showing the scalar multiplication I just did. So I've got my component form right here. That is what I'm going to graph. So 2 and -5. Starting from here, I need to go 2 spaces to the right, -5 spaces. That means 5 down. Click. Okay. And then one vector to show the resultant starting from the origin. So that was the confused student wandering around the neighborhood this way and then that way and then stops and whistles. Now I'm going to draw the pigeon. So starting from home, click. And then you can see how this thing follows my cursor around. I'll move that right to where the student is. Click. Submit. Yay! And then the component form of the resultant, that's what the pigeon just did. The pigeon is starting at the same place as that confused student, ending at the same place. It's they're equivalent, just different paths. So +2 and -4. Pointy brackets, 2, -4. Yay! You can see all those parts are correct. Yay! Here's number 9. Um, Number 9. Okay, consider the following vector addition. So I got -1u plus 3v. So this one, the vectors have been named, and then those individual vectors are defined below. Uh, so -1 multiplied by the top one. So we're going to break this into parts. We're going to do a couple of scalar multiplications. You can see this problem's got 4 parts. So first part, we're going to do that scalar multiplication, the -1 times vector u. So u is -1 and 3. If I multiply both of those components by -1, I need pointy brackets. It'll be +1 and -3. Close my pointy brackets. Submit. Yay! Now I'm going to do the second part. I'm going to do that scalar multiplication. Find the component form of 3v. So if I take vector v, multiply both of those components by 3, brackets, -6, comma 3, close my pointy brackets, submit. And then I get to graph. So I'm going to graph these two components that I just gave. I did the scalar multiplication. I'm going to use that to create the graph. So I'm going to have one vector to show -1u, right? That's what I just typed in here. So starting from the origin, over 1, down 3, click. From the end of that vector, so starting right here, I'm going to graph -6, 3. That's the 3v part of this vector addition. So click 1, 2, 3, 4, 5, 6 on the x direction, 1, 2, 3 in the y direction. Click to end that vector. And now I need one vector to show the resultant. So that's going to come from the origin. Here goes the pigeon. Blam to the student. Submit. And then it's going to ask me for the component form of that resultant. Well, the pigeon just was straight to the left by 5 spaces. So it's going to be in pointy brackets, -5, comma 0. Close my pointy brackets. Submit. Awesome. There it is. And then let's jump to 12. Okay, consider this is like the same as the one we just did. I don't think I need to do 12 also. Let's I remember. The scaling on the graph is going to be different. Some of these problems have bigger components, bigger scalar multiplications. So some of the numbers are going to be bigger. The graph scale may be bigger. It might look a little different. I don't need to do anything different on this question. It's the same process, just bigger graph. So let's jump to 14. Here's the last one. This one has no graphing. This is just numbers. So here are my two vectors. Vector A is defined by -1, 4, and vector B is the components 0 and -3. I'm supposed to do this arithmetic on the vectors. So -3a minus 2b. So it's a subtraction question, so I know I'm going to have to change that mentally or written out on my paper to -3a plus -2 times b. And we can just do this whole thing on paper, add them together. I'll attempt to walk you through it because I know you can't really read my paper. I should write it on a different screen probably so you can actually see it. But here's the mental math version. So I got I'm going to do the x components first. I'm just going to type in my x component into this. So the pointy brackets are already here. I've got separate answer blanks for my x component and my y component. So let's just do the x first. So I'm going to take this x component and I have to multiply that by -3. So -1 times -3 is +3. And then I need to add that to negative 2 multiplied by this x component. Well, I know 0 times negative 2 is still 0, so this is going to be 0. So positive 3 plus 0, positive 3. Okay, let's do the y components. So I'm going to take this y component and multiply it by the scalar of negative 3. So that's going to give me 4 times negative 3 is negative 12. Remember that. And then vector b, so I have this y component of negative 3. I need to multiply that by negative 2, and so that is 6. So I've got negative 12 plus 6, which is going to be negative 6. It's going to go right here. Yay! All right. Well, I hope that is a good explanation for you, and good luck.